Good morning. So we're going to talk about angles and angle measure, and we're going to be moving on to the first alternative way of how to measure an angle. And it is in radian measure. So radian measure, so thus far we've only considered angles with the units of degrees. So we're going to be using another method of measuring an angle, and that second method is called a radian. So a radian is an arc. It's when the arc of the circle has the same length as a radius. So for instance, let us consider the circle that I have drawn right here. What I note is my radius is r. 1 radian, the measure, is the distance by the arc length between the initial arm, this, and the terminal arm. The arc length is equal to 1 radius, and that is a radian. Now, radians are very important, by the way. They sometimes simplify things in physics and in math because they are unitless. So if theta is equal to 30 and there's no degree sign written, this angle is measured in radians, or that's what it is communicating. Versus 30 degrees, you need to put that degree symbol up there to signify that you're dealing with degrees. Also, your calculator has Radian Mode. So right about this point, you should be maybe starting to consider, well, if I want to work in degrees, my calculator has to be in degree mode. If I want to work in radians, my calculator has to be in radian mode. So what we're going to do is we're going to create these special angles on the unit circle, and I really need to encourage you, don't be that intimidated by radians. Actually, I prefer radians. I really do. Start off with a little warm-up here. So I'm going to say, calculate. Now I'm going to say without a calculator. So calculate without a calculator the sine of 30 degrees. Well, sine of 30 degrees, that's my first related angle family. Here we are. 30 degrees is the angle that's closest to 0. The sine value, therefore, is 1/2. Now, if I were to calculate the sine of 30 degrees, even with all the math that I've taken in my life, it is very difficult, number one, to even know where 30 is, an angle of 30 radians. All right, moving on. So which quadrant is 30 degrees? Well, it's obviously quadrant number 1. In which quadrants is 30 radians? Now, trust me, I have no idea. Okay, I think I just lied to you, maybe, but I'm pretty sure it's in quadrant 4. It doesn't matter. Anyways, so radians look a little bit different. What I'm going to do now is I'm going to reconstruct the unit circle by just using radians. Now, an arc length, I like to think of an arc length as a partial circumference, right? It's the distance around the perimeter of a circle. So I could call this, by the way, this is in degrees. Don't write this down. This was 0 degrees. This is 180 degrees, and this was 360. Don't write this down, and then we could do the unit circle that way. I have to change the way that I think. So I'm going to start off with this. 0 degrees. I'm defining 0 degrees there. The next thing that I'm going to do is I am going to ask myself, what is the measure of one entire revolution? Well, if you notice, I just highlighted the circumference. And let's keep in mind that this is the unit circle. So the unit circle, why is it called the unit circle? Because the radius is equal to 1. And what is the circumference of a circle with radius 1? Well, the circumference, what I've just highlighted in pink, the circumference is going to be 2 pi times the radius, which is 1. So the circumference is 2 pi. So one full revolution was known as 360, but now it is known as 2 pi. And that is very important. So that's 2 pi all the way around the circle. So can you guess what another angle is? Now this gets kind of hard. Okay, let's piece it together. Well, if I know the whole distance is 2 pi, maybe a nice way to say is, what is half the distance around the circle? So this was formerly known as 180. So now I'm going to call this pi. If the whole circle is 2 pi, then half the distance is pi. What I find really, really helpful is measuring or having 2 points of reference, pi and 2 pi. Pardon me. Maybe we want to put another angle up there. By the way, now perhaps I'm going to define this angle right here, right? If we're talking in degrees, we would call that 90 degrees, but now we're talking radians. Well, if you notice, the arc is exactly half that of pi. So instead of saying half pi, we call this angle pi over 2. All right, so I'm just going to maybe, this was 0. This was pi over 2, or half a pi. This is pi. So what is pi plus another half a pi? Well, that's 3 pi over 2. I just want to introduce the notion of getting this. Another way of looking at it is consider that pi can be thought of as 2 pi over 2, right? So again, this would be 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, which is, or 4 pi over 2, which is 2 pi. So far, so good, I'm hoping. Now, I'm going to take a special angle family here. And I'm going to say, let's call this formerly known as the 30-degree angle family. So these are the angles that are formerly known as 30 degrees. What can you say about 30 degrees? Well, 30 degrees, like let's take this angle right here. This angle was exactly, like 30 degrees, is exactly 1/6 of 180. Therefore, this angle must be pi over 6. Now, again, how did I get pi over 6? Because it was 30 degrees in degrees, and 30 degrees is 1/6 of half a revolution. Half a revolution was pi, so this is pi over 6. Now this other related angle, well, it is going to be (5 pi over 6). Now, how did I get that? Well, I consider that pi is 6 pi over 6. This is really helpful. How far am I away from the x-axis, I asked myself. Pi over 6. So really, 5 pi over 6 can be thought of as 6 pi over 6, and then you have to subtract pi over 6 to get your second related angle, or second quadrant related angle. Now, this angle right here, well, I am going to go a whole pi, and then how far am I away from the x-axis? Another pi over 6. So what is, in other words, 6 pi over 6 plus another pi over 6? This ends up being 7 pi over 6. The last related angle family here is, by the way, this point right here, my 2 pi, I'm going to think of it as 12 pi over 6. Why am I thinking about it? Where am I getting this? Well, I'm trying to make connections with the pi over 6 family. So 2 pi is 12 pi over 6. So therefore, I have to go all the way around, which is 12 pi over 6. But then I have to subtract pi over 6 because I'm exactly pi over 6 away. So this ends up being 11 pi over 6. So there's my pi over 6 related angle family. And by the way, I can erase a lot of what's going on here and keep this a nice simple picture, right? What is the sine of pi over 6? Well, don't panic because you spent a considerable amount of time, right? We know that the sine of pi over 6 is 1/2. Are we good? So it's really about the location. The location on the unit circle. It determines the sine, cosine, and tangent of that angle. So it's all about location, location, location. Now, let's start off, or let's continue with this madness. So I'm going to maybe switch my colors to a nice blue, and I'm going to take this angle up here. I'm going to see this related angle family, right? They're all the same distance away from the x-axis. I challenge you to think of this angle up here. All right. Good. Pi over 3. You may be asking yourself, what? Pi over 3. Why pi over 3? Now remember that we're measuring the arc length. And just pretend, or just recall, that we're in degrees. This is was 30 degrees. This is going to be 60 degrees. Now, I haven't drawn it to proportion, which is kind of too bad, but do you not agree that 60 is double the angle of 30 degrees? Yeah, so what's the double of pi over 6? 2 pi over 6. And 2 pi over 6 quickly simplifies into pi over 3. So, all right, good times, right? So pi over 3. What is the angle in quadrant 2 that is related to it? Well, this would be 2 pi over 3. It was 120, but now we're going to call it 2 pi over 3. Alternatively, you could think of pi as being 3 pi over 3. Could you not? And this blue related angle right here is pi over 3 away. So that would be 3 pi over 3 minus pi over 3. Now the quadrant 3 related angle is going to be 4 pi over 3. We went exactly pi plus 1/3 pi. I'm hoping you're catching on. This related angle is going to be 5 pi over 3. Perfect. So now we have a whole bunch of angles going on here. Nobody said this was going to be easy or intuitive, but you'll get very comfortable with this. So this is called the unit circle in radians. The most important thing to do is to practice this. You may be spotting out that, Mr. Morin, we are still missing one related angle family. Absolutely. The related angle family we are missing is this middle one right here. So it was stuck, this one right here. It was stuck between 0 and 90 degrees, exactly in the middle. Well, instead of calling it degrees, what's the exact point between 0 and half a pi? Well, 1/4 of a pi, of course, or pi over 4. We're going to have related angles in each of the quadrants. This is going to be 3 pi over 4. This is going to be 5 pi over 4. And this is 7 pi over 4. Now, I quickly wrote those down, but they're fairly easy to remember because there is some pattern to these where everything's just an odd pi. 1 pi over 4, 3 pi over 4, 5 pi over 4. But let me ask you the very fundamental question. The quadrant 1 angle, how far away are we from the x-axis? Pi over 4. So to get my quadrant 2 angle, I think of this now as 4 pi over 4. Now, this pi is really important in terms of frame of reference. So, that wasn't good. I just erased all my points. So anyways, I'm going to take it, and I'm going to get to 3 pi over 4. How am I going to do that? I am going to go 4 pi over 4, subtract 1 pi over 4, because that's the distance away from the x-axis. 4 pi over 4 plus, or minus 1 pi over 4 gives me 3 pi over 4. Let's get to this related angle family, this one down here. I go 4 pi over 4 plus 1 more pi over 4, which 4 pi over 4 plus 1 pi over 4 gives me 5 pi over 4. Let me get over here, this one down here now. How did I get to that one? It says 7 pi over 4. Just like with degrees, we have to go all the way around the whole circle, which was 2 pi. And this, instead of 2 pi, you want to maybe consider that this is 8 pi over 4. Whoa, that's too far. How far is too far? Exactly 1 pi over 4. So it's 8 pi over 4 minus 1 pi over 4 gives me 7 pi over 4. And there's the unit circle. So I think some important ideas are, what is the reference? So I'm just going to say reference pi and 2 pi, and try to be creative in the way that you write it like this. And by the way, I should have also written as 6 pi over 3 here, right? They're all the same thing. They're all just simply 2 pi. Very, very important. And constantly ask yourself, how far am I away from the x-axis? Now, please note that I haven't attached sine, cosine, or tangent to any of these points, but I really don't need to talk about them because you already know. For instance, what is the sine of pi over 2? You can recall from your previous learning that it's 1. That's the y value. What is the tangent of 5 pi over 4? Well, that position before was called 225 degrees. What is the tangent of 225? Well, it's the same thought process. If you conceptualize the unit circle with degrees, the tangent of 5 pi over 4 is 1. Similarly here, let's take a look at 7 pi over 4. The tangent of 7 pi over 4, well, these two are related. Now notice how the denominators are the same, but tangent in quadrant number 4 is negative. It's -1. The tangent of 7 pi over 4 is -1. All right, I'm sure we're going to practice this tons, so I'll stop this video. Good luck.